So, good morning. We're going to start a unit on rational expressions. Just a review for you, if you remember what a rational number is. A rational number is any number that can be written as a fraction. So, for example, a half would be a rational number. 3 would be a rational number because you can write that as a fraction. Decimal 5 would be a rational number because you could write that as a fraction. So today we're going to talk about rational expressions, though. What's a rational expression? Well, basically, it's a rational number with variables in the numerator and denominator. Okay, and so the problem with that is there's a little bit of a glitch when it comes to what those values of x could be. So if you look at our first expression here, 6 over x, well, if x is 2, no problem. 6 over 2 is 3. There's nothing special there. But if we have 6 over 0, that's a problem because you can't have 0 in the denominator. So this one is actually what we call undefined. All right, and so that's something we need to become aware of. What happens when there is a 0 in the denominator? Okay, so let's quickly fill out this little chart here, and you can see that for the most part it doesn't matter what x is. Okay, so we'll try this next one. If x is 2, in this case you're going to have 8 over 4, which is 2. No problem. Here we have 4 times 0 over 0 plus 2. What is 0 over 2? Well, that's 0. So interesting, if you look at the one right above it, here 0 x can't be 0, but on the second one, x can be 0. Alright, and if we put x is 1 in this one, again, that's no problem. So 4 over 3. By the way, we'll leave these as fractions. We'll stay away from the decimal form. Okay? So I'll give you a few minutes to fill out this form. Okay? So checking over all of those expressions, those are all rational expressions. And note, where the denominator is 0, we have undefined expressions. Okay, so very quickly, a rational expression is where the numerator and denominator of a fraction are polynomials. If you remember, a polynomial is terms with variables in them. Not necessarily with variables, but could have variables in them. Okay, and those values of where the denominator turns to 0, those values are called non-permissible values. Okay, non-permissible value, NPV, or restrictions on the variable. Okay, we'll use both of those words to describe the situation. Okay, so what is a rational expression? This is not a question that you're going to see very often, but just recognize that all of these expressions have x's, y's, other variables in them. But if you notice here, there's a variable in the exponent, and here there's a variable in the radical. These are not rational expressions if those things happen. Okay, you're not going to see those. At best, you might see a multiple choice question that says which of these is a rational or which is not. So keep that in mind. Make sure you just kind of review that before your test. Okay, so here are a couple of rational expressions. Let's take a look at them and try to decide what are the NPVs of these expressions. Okay, and sometimes you can just look at them and visually you'll be able to see it. My suggestion though is let's do this with some algebra. So we know that this can't be 0. Okay, so I'm thinking x squared minus 9 can't be 0, so let's find out when it is 0. Alright, and generally speaking, we're probably going to factor. In this case, we could go x minus 3, x plus 3. Alright, and so then what values are going to make this 0? Well, plus and minus 3. So those are the NPVs, because really that's what x cannot be. Okay, so therefore the NPV x cannot be plus or minus 3. Now I'm not sure if any of you saw this and said, I wouldn't have done it that way. I would have said, I'm going to solve it using perfect squares. that's fine too. Okay, same answer. All right. Let's try the next one. This one would be a little bit harder to do by inspection. In fact, I don't know if anyone would do this by inspection. Okay, again, what we're going to do is we're going to say, when does this equal 0? The good news is we should be pretty good at this. This is solving for x. This is what we've spent a couple of units doing. Okay, so need to be able to factor this. What is it factored? X minus 4, x minus 4. So x is 4. That's the value that's going to make it equal to 0. So the NPV then, x cannot be 4. 4 would give you a value of 0 in the denominator, and you can't have that. Okay? All right, one more concept that we're going to cover here is the idea of what is an equivalent form of a rational. Okay? For the most part, when you see equivalent, they're usually thinking about, can you simplify this? So if you think back to fractions, how could you simplify 12 over 18? Well, normally you would say, I see there is a factor possibly of 3 there, and this would be a simplified version. Okay? But the reality is you could actually also make it look like this. That's also equivalent, but not simplified. Okay, and taking a look at this, what is it that makes them equivalent? Makes them equivalent if you're multiplying by 1 or if you're dividing by 1. Okay, any version of that is going to make them equivalent. Generally speaking, we're going to be looking to simplify, not make bigger. Okay? So let's take a look at a rational expression. All right, so now we're going down to rational expressions right here. These are the ones with variables in them. Okay, and if we multiply both the numerator and denominator by the same variable, you end up with an equivalent expression. Okay, this is equivalent. All right, we can also divide by 1. Again, this is equivalent. Now, it's important to notice that what did we multiply by? Well, we multiplied by x. We divided by x. In other words, we did not introduce a new variable. All right, so just taking a look at that expression that we have here, this would not be equivalent. I would not want to multiply by y over y. Even though this equals 1, this is not going to be equivalent, because what we've done is we've introduced a new variable or a new non-permissible variable. Y can't be 0 now. While it could be there, it can't be there. Okay, so keep that in mind. Again, this is not a big deal that we're not going to be looking to make things bigger. We're going to usually be simplifying, so generally speaking, we're not going to be multiplying. We're just going to be dividing by variables, and there you won't be introducing a new variable. Okay, you'll see what I mean as we do some of these examples. Okay, so looking at this, this is a rational expression, and I want to write an equivalent version of it. For the most part, what you're going to do is you're going to say, where can I simplify here? And a simplified version would be as if I would cancel out the x minus 1. These two expressions are equal. The only thing is I need to be clear here that x can't be 1 here, then x can't be 1 here. Now that seems a little odd because really x could be 1 here. But because we want equivalent expressions, we say x can't be 1 in both of them. Okay, so that is an equivalent expression. So this is like our first equivalent expression. Let's now try another one. Okay, this is something that I don't think we're ever going to do because, like I said, in math we want to simplify. But if we wanted to come up with a equivalent expression by multiplying instead of dividing, we could do this. For example, it's not the only thing we could do, but this would be one possibility. So I have x plus 5, x minus 1. And then on the bottom I have 2x minus 1. And now I want to multiply by something without introducing a new NPV. Well, remember, our NPV here is x can't be 1. So what I could do is I could multiply by x minus 1 and x minus 1. So now again, this is equivalent. It has the same NPVs. All right? So let's try a little bit of simplifying. Again, this is, when I say simplify, we are looking for equivalent. We don't want to change the value. And generally speaking, simplifying means you're going to reduce a fraction. Okay, and remember the fraction now has variables in it. Okay, so if you look at our steps, we're going to factor. You're always going to factor. Then you're going to identify the NPVs. And then you're going to simplify. Okay, it says divide the numerator and denominator. This is the simplifying part. Okay. So first of all, factor. Well, this one's factored. It's already listed as a bunch of factors. What would be the NPV for this expression? Well, looking at the denominator, this tells me that A cannot be 0. And then B cannot be 0. Okay, so there are the NPVs. Now let's simplify. Okay, so there's a fraction here. You have 25 over 35. There is a common factor of 5 there. If I divide the top by 5, I get 5. Divide the bottom by 5, I get 7. Okay, then I see there is an A in the numerator and denominator. If I divide that out, I end up with A squared. Then I look at the b's. Well, there is a b squared on top. There's 5 b's on the bottom. If I cancel out 2 of the b's, I'm left with b cubed. And then there's a c left. So that is a simplified version of that rational expression. Okay, next one. Well, this one's going to have to be factored first. How do we factor this? Well, numerator, I see there's a common factor of 6x. And if I divide out a 6x, I'm left with x plus 2. And the denominator is already factored. Okay, NPVs. What can, in this case, x not be? Well, if x is 0, we get 0 in the denominator, so x can't be 0. Okay, simplifying. Well, I see there is an x that could be cancelled, and I see that 6 and 3 can be simplified, so that I'm left with 2x plus 2. Now there is a 1 on the denominator, but you don't need to write that. Okay? Alright, next one. Maybe pause the video, try to factor this yourself. Okay? So, factored x minus 7, x plus 7, and I'm thinking there should be an x minus 7 or an x plus 7 in the denominator because something's going to cancel out, and in fact there is. It's x minus 7 times x plus 2. Okay, what's the NPV? X cannot be 7 and negative 2, right? I'm looking for right here and right here. And so if I simplify, what can be simplified? X minus 7 cancels, so I have x plus 7 over x plus 2. Now notice what the NPVs are. They are 7 and negative 2. If you look at our simplified version, really the only problem is a negative 2. But because these have to be equivalent, the NPV is still 7. So make sure when you're looking for NPVs, you always look at the original factored version, not the simplified version. Okay, let's do this one. Again, take some time by pausing the video to factor this yourself. You want to become good at this. So 2x and x minus 3 plus 1. And the denominator is 3 minus x, 3 plus x. NPV, x cannot be plus or minus 3. Alright, and then I look to simplify, and I'm going, well, there's nothing that is the same, except that these two look very similar. Okay, I'm going to put a little star here. This is something that you have to remember. This is going to show up a lot, and I know you've seen this before. X minus 3, 3 minus x. Those look the same, but they're not. The numerator, you have a negative 3. The denominator, you have a positive 3. Numerator, you have positive x. Denominator, negative x. They're really close. The only difference is their signs are flipped. So when you see this, here's what you're going to do. Okay, let's leave the top. And the bottom, you're going to factor out a negative. If I take out a negative, that's going to make it negative 3 plus x. Okay, so take a close look at that. What did I do? Have I changed those two expressions? No, they're identical. You can still, if you multiply that negative 1 in, you get positive 3. And if you multiply the negative 1 times x, you get negative x. These are the same expression. They just look a little bit different. Okay? And if you go a little further with that, if I rearrange the order in the bottom, you actually get this. And there you can cancel out the x minus 3, and you're left with negative 1. Okay? So what's the moral of the story here? Anytime you have two expressions, binomials, that just have the signs reversed, like this one, when you simplify, you end up with negative 1. Okay? So, here's my negative 1, and I'm left with 2x plus 1 over 3 plus x. Alright, I'm going to give you a little bit of homework. I'd like you to try on page 527, numbers 4 to 8, 10 to 12, 14 and 15. And on the My site, there is a worksheet called Simplifying Rational Expressions.